Good morning. Today I will discuss the kinetics of the chain reaction, and in this lecture I will concentrate only on the thermal chain reaction, and there are many types of thermal chain reactions, but I will cover one of the most important hydrogen halogen chain reactions, and that is H2 plus Br2 reactions. Now there are basically two types of chain reaction. One is called non-branch chain reaction, that is also called the stationary chain reactions, and this is normal type of chain reaction, that is H2 plus X2. This is non-branch or stationary chain reaction, which is control chain reaction. And second is the unbranched or the non-stationary chain reaction, like the H2 plus O2 reaction, like that. Why H2? Because it is sometimes explosive reactions. Now, basically the unbranched chain reaction and most popular chain reaction is hydrogen and bromine chain reaction, and it was discovered in the year of 1913 by a great German scientist, that is the Max Bodenstein. And chain reaction also, there are two types. One is thermal chain reaction, that means temperature is responsible for that, like this reaction. And another is photochemical chain reaction. Photochemical chain reaction. And in photochemical chain reaction, the photons are responsible. Although it has been discovered by the Max Bodenstein, but there are some problems, and the other scientists like Michael Polanyi, Christensen and Hirschfeld, they also studied large number of chain reactions, and then ultimately we are able to figure out the mechanism of this chain reaction. Now, as I told you, that one of the most important example of explosive type of the chain reaction, which is branch chain reaction and non-stationary, because it is very difficult to control such type of the chain reactions. And most of the chain reactions are very complex rate equations and with fractional order and mixed order type of the reactions. Now, the photochemical chain reaction was proposed by Nernst, and they have studied the HCl reactions. And as I have already told you, that photons are responsible for this type of reaction, and quantum yield is to be determined. Now, why chain reaction is important? Now, if I simply write this H2 plus Br2 reaction, now if I want to write the rate law, you will see a different types of example, like H2 plus Br2 half, then 1 plus HBr divided by Br2. So in order to determine this kinetics of the chain reaction, we have to take the help of steady state approximation method. Steady state approximation method. And second, that we must know the mechanism. Or different elementary steps. And on the basis of this mechanism or the elementary step, we can determine the final rate law. Now you know that there are other types of the chain reaction. H2 plus Cl2 twice HCl, H2 plus I2 twice HI. Now the question arises, what about the HCl and what about the HI? Is it a chain reaction? It's a big question. Because it composed of large number of steps, energy of activation of each and every step is important. I am giving one example. Now here there is a comparative statement of the activation energies of the hydrogen-halogen reaction, and it is available in the books of the chemical kinetics by K.J. Ledler. Now the overall energy of activation of this HCl reaction is 210, here is 190, 170. But when I see the individual energy of activation, then you see the first step, the formation of free radical like Br2 to Br or Cl to Cl is 234, it is 192, it is 142. But one of the important steps, that is propagation step, when this hydrogen react with this either chlorine or bromine or iodine, this step energy of activation is 25 kilojoule per mole, and it is 72, it is 140 kilojoule. Whereas here you will see that this step very high activation energy is required. So therefore, sometimes what happened that this steps is not very, this reaction is not very popular. You know that there are three steps. One is initiation, another is the propagation, another is the termination step. So let me explain only one reaction, that is so we should start from here. Br2 is converted into Br and Br. This step is K1. So it is initiation step. Then this Br is react with hydrogen to form HBr and H. This is propagation step. Then this again Br2 plus hydrogen, it is HBr and Br. It is again, it is also propagation step. Another step is HBr plus H, H2 Br, it is K4, and last step it is a termination step. Br again react with Br, it will form Br2, final product, and it is K5 step. Now if I want to write the rate laws, it will, rate is equal to some constant H2 Br2 half 1 plus some J HBr divided by Br2. So I have to determine this law with the help of steady state approximation method. So first I must write or main d by dt of HBr this is our main reactions. So in first case, here is HBr is formed, so we can write K2 Br and H2. Then again HBr is formed, K3 Br and H2. And here is also HBr is consuming, so it is minus K4 HBr and H. So now there are two intermediates, I think this and this. So we have to remove this intermediate from this main equation. So first I will do the for H. So here it is produced, so I can write K2 Br H2. Second case, it is consumed minus K3 then again it is consumed, so minus K4 HBr and H. So applying steady state approximation, if it is equal to 0, so I can write like that, K2 Br H2 is equal to just a minute. So taking common H, K3 here 2 H plus K4 HBr. So I can write H is equal to K2 H2 divided by K3 here 2 plus K4 HBr. So first part is over. So I can write here H is equal to K2 Br H2 K3 Br2 plus K4 HBr. Now I have to determine the another intermediate, that is the Br. So let me erase all this part. So same thing, dy dt of Br. So from here Br is produced, so K1 Br2 like that. Again, it's consumed minus K2 Br H2. This step. Here again it is produced plus K3 Br2 H. Here again it is produced plus K4 HBr and H. And last minus K5 Br because there are two Br. Now if I equate these two equations, so you will see that this part is eliminate, this minus plus, this plus eliminate, this part. So applying steady state, so we can write K1 Br2 is equal to K5 Br square, because we have to determine the Br. So Br is equal to, just take a look, Br is equal to K1 divided by K5 and Br2. So under root of K1, K5 and Br2. So therefore Br is equal to K1, K5. You can write like that also. Half. So I can now erase this part. So now we have hydrogen as well as Br. So I can substitute the value of Br in this equation. But before that, what I do, so I can rub this part also. We don't need this thing. So you just see here, H is equal to, just from here you see this part. So K2, in place of Br I can write K1, K5 like that, Br2 half, then of course H2 divided by K3 Br2 plus K4 HBr. Now we have to substitute the value of H in our main equation. Now before doing this final equation, what we have seen that, can I write this K2 Br2 minus K4 Br like that, this portion. This K2 Br2 minus K4 HBr is equal to K3 H Br2, that part actually. So therefore I can write simply in this place, what I can write? I can write d by dt of HBr is equal to, because this part is equal to this 2 K3 Br2 and H. So I have to substitute the value of H from here and you will get the final equation. So that is 2 K1 K5 like this, then K3 Br2, then H2 Br2 half divided by K3 Br2 plus K4 HBr. Now, if I divide both numerator and denominator by K3 Br2, so what I will get? What I will get, and suppose this part is K2 is also there. Some constant K dash. It may be K1, K5, 2K2 like that. It is a constant. Then H2 Br2 half divided by this, divided by, so it is 1 plus this K4 and K3. Then we just remove all these things. HBr divided by Br2. And this part is also, you can write small j like that, a constant, small j. So you see that rate is equal to K dash, whatever it is, H2 Br2 half 1 plus small j HBr divided by Br2, which is very similar to this one. So by this method we can figure out the final rate law of this most important hydrogen bromine chain reaction. And on the, if you understand these steps, then you can also write the H2 plus Cl2 reactions. But remember, these are thermal chain reactions. Thermal chain reaction. Example of thermal chain reaction. And the derivation of photochemical chain reaction also very similar to this type of thing, but in photochemical chain reaction we have to consider the intensity of the absorbed light and also calculate the quantum yield. In next class I will discuss the photochemical chain reaction, but this is actually thermal chain reaction of H2 plus Br2 reaction. Thank you very much.